tutorial will be about OMFIT classes. It's a big topic, so we won't be able to cover probably everything, but we'll cover as much as we can. And to start, Sterling is going to give us kind of an overview of what is a class, what is an object, and a bit of the ideas behind object-oriented programming in general. And then we'll dive more into what are OMFIT classes and pick a few examples here and there, and talk about some special classes that are really specific to the framework. And finally, we'll hopefully have time to go over creating a simple class of our own and add it to the framework. So,
all right. So I've written a little script here that I will hopefully add to the tutorial module that kind of gives us the basic flavor of what a class is. So in Python, what is a class? A class is the structure that holds all of the definition of an object and all of the methods that can act on that object. So we started with a very simple class here. This class is just called living. It inherits from the Python base object, which you should do for all classes. And we have some doc string here that tells us what this class is about. And then we start to define the methods that define this class. So every class has a very special method called init, __init __. And that method is always called when you instantiate a new object of that class type. So in our case, we want to pass it whether the living object is alive or not, and then we set the attribute of our object. So self is always the first, by convention, is the first argument of this function, and then other arguments and keywords can follow. So self is our current object that we're operating on, and then we're going to assign alive to our attribute of ourselves. And then define another attribute here, just kill, and we say, well, if we kill it, then we set alive equals false. So I want to show.
So just to say that when you're in a class, a variable that is attached to that class is called an attribute, and a function that is attached to that class is called a method. So when you hear method or attribute, these are functions or variables that are associated to that class. It's just a nomenclature, thing.
That is right. Okay, so that is the actual class definition. We then want to instantiate a class. So I'm going to make a virus. It's living, and then I'll print whether it's alive. I will access the actual attribute of this instantiation of living, and then finish. Over here, we do that. We print virus is alive. True. Okay, that's great. So we don't want to do that anymore. So we'll set that to false. And so then I have some other class definitions here. And what we can have is we can have a future class that derives from a previous class. So here we have the mammal class. It derives from the living class. And what did we do in mammal? Well, we said that it could have an age, and we could pass it any other keywords. And down here we see in the doc string of the init method, the age is just the age of the mammal. We also have that any of these additional keywords are passed on to living. And so this is the way that you can call a base class's, a superclass's method. So living.init, and call it with self, and pass it the keywords. And so then we're gonna define a.
And this is an example of subclassing, right? In technical term, we can say that the mammal class subclasses the living class. And the cool thing about object-oriented programming is that all of the attributes and methods of the superclass are automatically inherited from the lower class.
Right. All right. So then we defined a few other classes here. Person is a subclass of mammal, and dog is a subclass of mammal. There are tests that you can do for classes, like you can ask if dog is a subclass of living, or mammal, or person, or if mammal is a subclass of dog. So let me go run that script, and we'll see that over here. We see that dog is a subclass of living, sure, and dog is a subclass of mammal, sure, but dog is not a subclass of person, and nor is mammal a subclass of dog. So that doesn't work backwards. All right, so then we'll comment that out. And so those are just operations on the classes themselves. Then we want to look at objects that are instances of the classes. We have some protozoa, a dodo bird. We see here that dodo birds are not alive. And we have Sterling and Orso and Fido. And so we can instantiate them. Oh, my bad. Orso is alive, yes. The dodo was not alive.
He's 11.
Or you would have said that.
Oh,
It's a bit false.
that's okay. I just wanted to see here that in the script run, we now have these different instances of an object of type living. The dodo bird is of type living. Fido is of type dog. You can see over here the data type. And our classes, their data type is technically a type. So then finally we can do some instance tests. We can ask if one object is another object. That checks to see if those two names are actually pointing at the same thing, which in this case they're not. But then we can also check to see if Sterling is an instance of person. I'm not a subclass of person. I'm an instance of person. If I'm an instance of dog, if Fido's an instance of living, if protozoa is alive, we can call the method of protozoa to kill it and see that it will be dead. And then ask the question, is Orso greater than Sterling? And see what the results. So I press F5 to rerun it. And of course, as Orso pointed out before, I forgot to set that true. So Orso is Sterling? No. Sterling is an instance of person? Sure. Not an instance of dog. Fido is an instance of living. Protozoa is alive, and then we killed it, and then protozoa is not alive. And is Orso greater than Sterling? Apparently not. But you can implement you might ask yourself, what exactly is greater than doing? And truth be known, I don't know exactly what it's doing, but you could go back up to the person class and we could define the greater than as return self.age greater than other.age, and then it would be definitive what it meant, and so Orso is greater than Sterling, given the ages and the instantiation of those. All right, so that's kind of a brief overview of what inheritance is of classes in Python, and anything more we want to say about general inheritance?
No, I think this is kind of the basic inner workings of classes, and I think it's also good to make a distinction of what is a class and what is an object, and then the different nomenclature that goes with with those two types. Okay, so why having this tutorial? And the reason is because in OMFIT we're dealing with a lot of different types of objects. Each one of these objects inherits from different classes, and there is a lot of subclassing. And so it appears to be appropriate to go over this. So maybe Sterling can show us, or if you want me to take it, or for example, this is an example of the complex inheritance that some of the OMFIT classes can have. So here we're looking at the doc string for the OMFITtranspNamelist class. And you can see there that there is the method resolution order. So in all of these inheritance, some methods could override, some methods of the subclass could override the methods of the parent class. And so this method resolution order tells us that the OMFITtranspNamelist class inherits from the OMFITnamelist class, which itself inherits from namelist file, namelist name, and then finally SortedDict. And then which itself is a dictionary, and then the inheritance continues. There is also an inheritance on OMFITascii, OMFITpath, OMFITobject, and then finally object. So not all classes are so complex, but this is just to say that when you're dealing with objects with these classes in OMFIT, there's often a stack of classes, and this works great, for how OMFIT works, because often we have to deal with files. So you will have a class that is capable of handling file, and maybe you have files that are only ASCII and files that are binary. So there is a class for ASCII files, and with all the methods that are associated with that. And then you can become more specific. A nameless file, for example, is an ASCII, is a type of ASCII file, and so you can have the methods and attributes associated with that, which will be different, for example, from a G file, which is also an ASCII file. So maybe I'll take over the. Let me see. How do I want to. Share. Okay. So we wrote a little walkthrough, and if anybody has questions, feel free to ask. So to show some inheritance, I want to start from the OMFITgeqdsk class. It's actually useful to use this graphical interface to look at all the classes. These are all the classes that are defined within OMFIT. You can see that there are many. We can search here for geqdsk. We select it, and let me open a file, a sample file from it. Okay, so OMFIT source samples G, and we load this G file as we usually do. Okay, and actually, what we can do is I'll show you the source code of that class. Let me see if I already have it. If I have it here already. So when we imported the G file, you can see here the OMFITgeqdsk class. Here it says OMFITgeqdsk. So all of these classes that are use case specific, they are stored in the OMFIT source under classes, and in this case, this one is under the OMFITgeqdsk file. So if we go to our source code, we can see, if we look at under the tree, under the OMFIT folder classes, here we see all of these files that contain the classes definitions. And so if we go under OMFITgeqdsk, we get we get to this file. And here, if we collapse everything, we can see that there are multiple classes defined into this file. But we are, focusing on OMFITgeqdsk. We can expand it, and we see that this class inherits from SortedDict and OMFITascii. So the the SortedDict class is it's almost like a dictionary, but with a lot more functionality. For example, SortedDict at the very basic level, SortedDict allows reordering of the entries in the dictionary. It also supports indexing of or accessing the keys in a case-sensitive or a case-insensitive way. And the OMFITascii class is another OMFIT defined class that, as kind of the name suggests, is able to handle ASCII files. So if we look at the methods of this class, we see that there are some of the methods that Sterling talked about, like the init method to instantiate this class. We can look at it. As we can see, this class expects a file name and passes that file name to the OMFITascii class. And if we look at the SortedDict instantiation, here we see that this class is, for example, case-insensitive. And here are some attributes. What I would also like to point out is that this class, as you can see, defines a lot of methods. And so, for example, when we instantiate a G file, an object of this class, all of these methods become available. So, for example, given a G file, if we want to take the surface integral of a given quantity, we can we can call this dot surface integral method, and this is where things are defined. There are some methods that are special in OMFIT, and these in particular are, for example, the save method, and that you can see here, the load method, and also the plot method and the run method. So the save method is the method that will take the content of a file, however it is formatted, and translate it into a Python dictionary. Okay, so this is an example.
No,
Sorry, that's the save, right? I said load. So this is how the ASCII file, the ASCII G file gets parsed and put into the object itself. The save method does the reverse. So from a dictionary, it generates the ASCII file in this case, or generates the file that of that the native format of a G file in this case. Other two special methods are the plot method and the run method, and these are methods that are executed when in the OMFIT tree. For example, if we go here, if we hit return, these are the methods that are executed. So, for example, this file, this OMFITgeqdsk class has a plot method, and because when we go in the OMFIT tree, we hit return. This is what gets called. Okay. So going down the list of things to show, as we said, there are many OMFIT classes organized by topic, loosely organized by topic. Let me show you, for example, the OMFITstatefile. So this is a 1.2 here. And again, if in doubt, we can come here. We can search for state file and see that it's in the OMFIT12 file. And so the OMFIT state file we see inherits from the OMFIT netcdf class. So this class, the netcdf class, knows how to load and save itself. And as we can see here, there are many additional methods that are defined.
That are specific to the state file.
That are specific to the state file. Yeah, thank you. Some are for plotting. Some are again for integrals and more physics-related things. Other examples of the same approach are, for example, the OMFITgenray class. I think Genray, very similar, and the JSolver class, for example. As we said, so for example, the Genray class here doesn't have to define the save and load methods. This is because these methods are defined by the netcdf class. So the netcdf class knows how to read the netcdf file, the binary netcdf file, make its representation in the OMFIT tree as a dictionary, and then save that back. So these methods are, when we use the OMFITgenray class, the save and load are directly defined in the OMFIT another example where that's not the case, for example, so if we look at, I think we had Chombo. This is an example where this is a class, okay, which again inherits from a SortedDict and ASCII. And in this case, the load and save methods are defined, okay. So again, this is how we go from a text file to a dictionary and back. And one important thing to point out is that these load and save methods, they have these, it's called the decorator before their definition. So without going too much into the detail of what a decorator is, you can think of these decorators as a wrapping function around the whatever attribute or method they are written before. And so what these decorators do is that they allow OMFIT to load the content of a file to memory only when the user requests data underneath it. And so in the example that we had before, so if we put back, if we reload our G file, you can see that when you put an object in OMFIT, if the string here is written as in italic, it means that the data has not been loaded in the OMFIT tree. And that instead, when we load it or we try to access the content of it, the string becomes from italic to regular, and it's a subtle change, but that means that the data gets loaded in the OMFIT tree. And yeah.
Do you want to point out how to unload memory from?
Right. So what these decorators do, what these functions do, is that they look at this attribute to the class dynaload, and if that's set to true, it means that the content of the file has not been loaded yet. So when we try to access something in the of the object, what will happen is that as we access, this dynaload function will be called, load will be called, and the dynaload will be set to false. So if we for example try to do dynaload, so this would be false. If we reset the state of the object to be off of memory. We can do this by right-clicking, and there should be a close, and we call close, or even from the command line, if we do dot close. Now we see that the object gets unloaded from memory, and that the dynaLoad attribute is set back to true. And all of these, the ability to dynamically load and closing and offloading things from memory, this is all inherited from the SortedDict class. Okay. So I talked about the save method, the load method, the run method, the plot method. There are two more methods that are quite special, and they're used in very rare situations. And these are the __3 representation method and the save keyword method. If we look at the G file, the geqdsk class, you see that these methods are in fact not defined, but we can use this as an opportunity to define it for another class that we can make. So let's see, and I will use this to also illustrate what these tree representation and save keyword methods do. So if we go to our command box, let's say that we want to create a new class that will inherit from the OMFITgeqdsk class, and we're going to add those special methods. So we're going to make a new class myOMFITgeqdsk, which we said is going to inherit everything from the OMFITgeqdsk class. And then here we can define these new methods. So we're going to say define, and we're going to define tree rep. And this method, the tree rep, let's call it tutorial OMFITgeqdsk class. Okay. So this tree rep method can return a string. Returns actually a list with a string, which it can be hello, and also some tags, but I'll skip on that to keep things simple. Okay, and we can instantiate this object in the OMFIT tree. So OMFITtutg, okay, going to be an object of this class, and we're going to take it and we can generate it from the file. So actually, filename is an attribute of everything that inherits from OMFIT object has this filename attribute. The gfile class inherits from that, and therefore it has this filename attribute, and we can use it to set the filename that we're going to pass to our newly created class. Okay, so hopefully this will work. And now you can see that what this tree representation function does, and what it does, it sets what should be written here in the content for that object. Okay. So again, this is quite special. It doesn't gets used very often, and if you don't specify, that is inherited from the OMFITobject class again, which tells us what is the file name and what is the file size. Now, before we go any further, let me try to save this project. So I'm going to save this project because I want to illustrate how these objects get saved in an OMFIT project. So let's call this classes tutorial. Okay, and I won't save this as a zip file. Okay. So my project is saved in this folder. So I'm gonna do file. I'm gonna open under my home directory. There is let me see, OMFIT data projects. We call this classes tutorial, and I'm gonna open that. So this is the content of this directory, and you can see that under the directory we have the G files that we have saved, and there is also this OMFITsave.txt. So this OMFITsave.txt is basically defines what is the content of a project, and this is what OMFIT reads, for example, when we are loading a project from zip, or when we're loading a project from the directory. And so, for example, we see that under the G, OMFITg, there is an object of type OMFITgeqdsk that OMFIT should load the G file that is under the same directory. Here there is 2G, which is of type tutorial OMFITgeqdsk, and as you can see, this G file is instead loaded into this weirdly named directory, and then the G file name again. Obviously, this directory is added ad hoc by OMFIT so that we can have objects with the same name at the same level. Objects with the same file name at the same level in the OMFIT tree. Okay, so you can see this here. So now, let's say that this is all okay if our class, all it needs is a file name to instantiate itself. But what if we want to pass some arguments to our class when we instantiate it? So, for example, when we instantiate our class, we can pass some arguments, some extra arguments. So, for example, if we pass the argument, the resolution, and we set it to an integer, say 1 or 2. What this will do, so let's see. So this argument, okay, will set how much the resolution of the flux surfaces that are traced from the G file, by how much the resolution should be increased. Okay, so let's do that. And let's save this project again, and let's look at what happened to our OMFITsave.txt. And so here we can see that OMFITtut at the very end, this extra parameter gets added there. The way this works is perhaps a bit convoluted, but I'll try to explain it. And this is it. Okay. So here we just have to kind of follow the white rabbit. So try to stick with me. So the OMFITg file class, okay, geqdsk class, allows for these extra parameters. Okay. These extra parameters are passed to the OMFIT ASCII class. Okay, so any extra parameter that is passed to the OMFIT ASCII class becomes available as in a dictionary that can be accessed as a dot with the attribute OMFIT properties. So if we look at here, for example. If we do .OMFIT and we print it, we can see that OMFIT property attribute OMFIT properties is indeed a resolution 1. And what happens is that this OMFIT properties dictionary is exactly what is what is added here as the last argument of the line that in the OMFITsave.txt. Now I talked about one more special methods, and this was the __ save keyword method. And so just to illustrate what that does, let me define it here. We define it here. And what this method does, if we define it in any of the kind of use cases classes, it will override the OMFIT properties that are typically saved at the end of the OMFITsave.txt. So if we return a dictionary here, and we set a resolution, and we set this equal to 2, for example, when we save our project, we will see that indeed the resolution here is changed to 2. Okay. So again, this is one of the things that it's there. It's used very rarely, but sometimes it's useful, and I want to cover it. Now, a few more. Maybe let me talk about a couple more special methods. Sorry, attributes of the OMFIT of the OMFIT object. So if we look at this G file, we can see that this is its file name. Okay, let's load this file again. Okay. So we're putting under OMFITg this object OMFITgeqdsk from this file. Now normally what OMFIT will do is it will make a copy of this file in its own working directory, and then when we save the project, it will save a copy of this G file into the project itself. Okay? Sometimes that's not what you want, maybe because these files are very large. And so here, if we look at show all class arguments, we see that there are a couple more class arguments that we can pass. And so, for example, there is the modify original and read-only attributes that we can pass. And these are attributes that are part of the OMFIT object. These attributes, these keywords change how the OMFIT objects operate internally. So if we say modify original equal true, this means that OMFIT will not make its own copy of the file, but instead it will refer to the original file for whatever operation it does on the file. So if we hit return, we see that if an object is in modify original, it will be highlighted yellow. The background will be yellow, and if an object is read-only, it will be highlighted red. So
can you click on each of those objects and then click P just to show that?
Right, correct. If we click P here, by default, clicking P, what clicking P does, it calls the __ rep _ method. And so, which for an OMFIT object by default is the file name. But again, like everything in OMFIT, it could be overwritten to something else. And so for the modify original, we see that we're referring to the original file name. And instead, for the one that doesn't have modify original, we see that it's indeed in the working directory for this project. And this can also be seen by looking at the file name attribute. And So let's save this project. And now if we look at what happened to the OMFIT save, you can see that now this G file, instead of looking into the current working directory of this project, it puts in the full path of the file, and it sets modify original equal true. Okay, so let me see. We talked about this. Okay. So now let me. We already saved this project. Let's close and let's see what happens. Okay. So I'm gonna close this project. We already saved it, and I'm gonna start. Oops, I'm gonna start a new OMFIT session. Actually, I could have just, I don't know why I did this. I could have just reopened the same project. Right, so so if we try to reload the project, now we're gonna run into an error, okay? And so why do we get this error, okay? And the reason is that if we look at
actually just go to this console log.
Right, if we go up here, it will say that 2G didn't load. Okay. And I think we have a pull request to improve the error message on this one, which didn't get merged yet. The reason why this cannot load is because this object here was of the type tutorial OMFITgeqdsk, which the OMFIT framework doesn't know anything about. Meaning, if we go here and we type, you know, if we try to access this, it just says, you know, this variable is not defined. Okay. So what we need to do to fix this is we have to make the framework itself aware of that class. Okay. So, like for all of the other classes, we will have to define a new. We will have to make a new object. So I'm gonna, under OMFIT source, OMFIT classes, I'm gonna make a new Python file. We can call it OMFIT tutorial. Tutorial class CLS. Okay. And then here we can copy the definition of the class that we wanted. Okay. Oops. And that's almost there, but not just quite yet. The best way to know what to do is probably to look at any of the other files. So let's pick, for example, I'm just randomly picking one. And here you can see that we have to import a few things. And so here we can paste these quantities. So this is not strictly necessary, but it makes it enforces that inside of this script, the print calls have open and close parentheses, like as for Python 3 requirement. This common startup imports a lot of things that are necessary for the OMFIT classes to work, and so we want that. And then instead of importing from OMFIT ASCII, in this case we have to import from OMFITgeqdsk, since our class here imports the OMFITgeqdsk class. We can import either everything or only what we want. And then this all tells OMFIT what are the objects, what are the classes that need to be made available inside of the namespace when OMFIT is running. So if we save this and if we close OMFIT again and we restart it, here we should see here that there should be a our tutorial CLS class file has been imported, and now when we open our most recent project, here now the framework knows what is the type, what is the class tutorial on OMFITgeqdsk, and therefore it can import it. In general, all of the OMFIT classes that are defined in this folder, OMFIT classes, they should be able to be, they should be importable also outside of OMFIT. And we can make that, we can make sure of that by writing maybe a little regression test right here. So, for example, this can be done by saying if name. This is the name of this script. This is the
name of the function that's being run.
Right. Okay. So this is the name of the function that's being run. If the name is main, okay, which means this is the top level Python script that is calling this this script, then we can instantiate this class. We can get the file name, for example, from OMFITsrc. OMFITsrc is one of the things that common startups makes available. Sorry, this is going to be fun. So under OMFITsrc, and then here under OMFITsrc, which is this OMFIT folder here, we know that we have to go up one folder. We will look under samples, and here there are a whole bunch of G files that we can use. For example, this one. So we're going to have G133.221.01000. And so in this case, we are loading the G file with our newly defined class, putting into this this object. We can load the object, and for example, we can plot it. Now, because we are outside of OMFIT, plotting, if we ran this, matplotlib would just not show us the figure. So we have to do import matplotlib or from matplotlib, maybe import pyplot, and then we have to do a pyplot show. And so now if we go back to our classes, and we said OMFIT tutorial CLS, and if I say run this, I forgot the polygon. So now this will be importing the class without the whole framework. It's able to load the content of the G file and plotting it. One thing that I want to point out is that so when your class is operating inside of the framework, the default behavior is to have modify original set to false. So OMFIT will make a copy in its own working directory. When you're outside of the framework, there is no working directory to copy things to. So the behavior is always modify original. So if we say, if here we look at, if we print the file name, and we say, let's say we print the modify original. Now this will be the original file name, and modify original will be true. Okay. So this is something to be aware of. Okay. I think I skipped a bit here and there.
But I don't think anything fundamental.
No, I think we talked about about dynaload and dynasave and close. We've talked about it. Yeah, I think this is all okay. So now all of what we talked about is about the classes that are under OMFIT classes. There are other classes that are not under that directory, and these are classes that are fundamental to the framework itself. And so instantiating these classes outside of OMFIT wouldn't make any sense. And these classes, these special classes, live under OMFIT tree, and you can see them here. There are quite a few, but the most important ones are the OMFIT Python task, OMFIT Python GUI that we've talked a lot in the previous tutorials. Also very important is the OMFIT tree class. It's the class that gets represented as a directory when we save the project. When we save the project, maybe I don't know if it's worthwhile showing this, but if we, for example, import a module and we import, for example, our classic OMFIT module. Now we see that there is a OMFIT module object, and then different objects of type OMFIT tree, and OMFIT Python tasks and Python GUIs. Now we can, I think it's instructive if we save this, for example.
I don't think you need to save it. Okay, well, sure.
Save it. And then if we look at, again, our, save it as a class tutorial. Oh, yeah, it's right here. Okay. So these are the two files that we had. And now we see the OMFIT object, which is of class, the type module. And this module and OMFIT tree, as you can see, get represented as directories when a project is saved to file. Whereas the Python tasks and Python GUIs become files. Okay. Okay, I think we did all this.
So actually on that point,
yeah.
Sometimes people get in trouble by trying to modify the OMFIT source in their local checkout of the repository. And if they add files or delete files, they don't understand why it doesn't show up in the OMFIT tree. And the reason is that they have not made the specified changes in the OMFITsave.txt for that module.
Right. The thing is that the OMFITsave.txt is actually how the OMFIT tree saves, is able to save things to file and reload. Okay, so it generates a directory and it puts in OMFITsave.txt file in it that describes how the files under that directory should be loaded. So it's not. So the way it actually works is that the OMFIT project itself inherits from the OMFIT tree class, and an OMFIT module also inherits from the OMFIT tree class. One way to see this, there are several ways to see this. For example, if we look at the OMFIT modules, if we look under modules, for example, OMFIT, and OMFIT, like any other module in OMFIT, we can see that there is this OMFITsave.txt. And so when we open it, this again tells the OMFIT module class, which again inherits from OMFIT tree, how to load its own content. And similarly, if we take any directory in OMFIT and we say deploy as, and we save it someplace, let's say under tmp OMFIT actually I should put it here. if we export if we deploy the IFIT scripts to this folder, if we go to that folder, we see that there is an OMFITsave.txt indeed here, which says how things should be loaded. And this is yet another example of inheritance. One more thing that I think may be useful. So now we have this tutorial class, tutorial OMFITgeqdsk class, and let's say that we want to make a change in the class. So let's say that we want to say def hello, and we want to print hello with that, and when that gets when that method is called. So if we try to take this object and we try to call hello on it, we'll see that it doesn't work because this object was instantiated and the class was loaded by the framework before we made that change. So for the framework to be aware of that hello method and the object to have that hello method, we would have to shut off OMFIT and restart the whole framework. One way to make the class to update the objects in the OMFIT tree to the latest version of the class is to use the reload Python method. If we say reload Python, and then here we tell it to look under classes, and then OMFIT, I think it's tutorial CLS, tutorial CLS. We'll see that what OMFIT has done is it updated the definition of this class in several in the namespace of several Python modules, OMFITx, and obviously the classes OMFIT tutorial CLS, OMFIT GUI, and OMFIT tree. And also it updated the OMFIT tree entries that of that type, so this guy. And indeed now when we call the hello method, this method becomes available. And I think with this, we hit the 1 hour, and I'll be happy to stop here. So I think just to recap, I think people now, if they want to write their own class for any reason, for a new code or a new file that a certain code generates, that file should probably go under the OMFIT classes folder. It will probably inherit from SortedDict, OMFIT ASCII, or OMFITobject, or variations of the above. And that's where the new class will be defined. It may be that you have to write your own load and save method to map from the file to a dictionary and from dictionary to file. And that's also where you can make your classes smarter by adding methods that can plot or calculate fancy quantities, fancy physical quantities. And once you're all happy, you can push those changes, and hopefully they will make their way to the official release of OMFIT, so that anybody who calls that class will have the class available. Okay.